What's up, guys? This is Drew. I am the SDSU EE tutor, and I know Midterm 2 is coming up soon for CompE 271. So I wanted to try and run through a couple videos that hopefully you guys can use as study material to go through and help pass your exam. So that being said, there's lots of material to cover, so let's get started. Alright, so the first thing for the exam is everybody wants to make sure that they definitely know how to write in assembly. Okay, so for assembly, let's take, this is a problem from an old Midterm 2 from 271. So let's work on this and convert this C code into assembly. So as always, we want to start with push L percent EBP. Alright, so this pushes EBP on the stack. So let's do that. So EBP is now on the stack. Okay, so on your exam, you should definitely draw this. Okay, draw the stack and show that you understand the structure of the stack and how it's set up, right? So just for quick review, so EBP gets stored on the stack. Always above EBP is going to be the return address. Okay. So then above the return address, you're going to get any function parameters, right? In our function count words, we have char my array, right? So the pointer my array will be stored directly above the return address, okay? And if this thing had other parameters, say it was like x, comma y, the parameters get stored on the stack from left to right, right? So that would basically be x would go there and y would go there, right? Left to right. But we don't need x or y. Let's continue. So move L percent ESP comma EBP. Right, so let's move the ESP to the EBP. And let's say that's our stack pointer. Alright, so that is what we did. We moved ESP to be pointing to the stack pointer. Okay. Now, the next thing that you're going to want to do is you're going to want to grab this value and store this in a register, because we will end up using this in our code. Right? You'll see my array over here. We're going to be accessing this address, so we will need this. Alright, so the way you do that is move L, so it's going to be 8% EBP. Alright, and we're going to want to move that to, let's move that to EDX. Okay, so this notation right here, this says we want the address that is EBP plus 8, right? So if this guy was 0x51370, right? That is the address of EBP. We want plus 8, right? And that is going to equal 51378, right? So in terms of the base pointer, right, this is where the base pointer is. This is 4 above the base pointer. This is 8 above the base pointer. The next one is 12, ... right? And then this is -4, -8, -12. Right? Realize that all we're talking about is addresses, right? Really, this address, this guy in your computer, I believe, is something like 0028F like 10 or some close to that. But this is the stack is just some address in memory, and all you're doing is you're jumping around and moving values in memory, right? You're just moving them on what's called the stack, and that's where you operate. And then this guy is just 4 above that, right? So that would be 28FF14, and then this guy would be 28FF18, and then so on and so forth, right? Right, so this line right here, this puts 8 above EBP, right? 4, 8 above EBP into EDX. Okay, so now EDX holds the pointer my array. Right, and realize that this is a pointer, right? So this value right here, this is an address. Okay. So the next line we have int I, and we see that I is equal to 0. So that will basically correlate to XOR L %, ESI, $, ESI. Alright, and so ESI is basically going to represent the integer I, right? And XORing it with itself sets it equal to 0. Because if you XOR anything with itself, then you get 0. If you don't believe me, try it yourself. So then we need to create another variable, words, right? And notice that down here we return words. Okay, so in assembly, EAX is a special register, because EAX is what the function returns. So whatever is in this register is what the function is going to return. So that means we want words to be stored in EAX when our function returns. Right, so let's XOR, right? They initialize it to 0, so let's XOR itself. Let's XOR EAX with EAX. EAX, assign EAX. Now that we have this stuff initialized, we can go ahead and code the rest of this stuff. The first thing we need to know how to represent is this array. Okay, so in assembly there is a specific format for accessing arrays. So let's take a look at that real quick. Alright, so what you do is you say, in parentheses, you have %some register, right? This register holds the address of the first element in your array. Okay, then ESI is going to be the variable that you increment each time. And then this value right here, this is the size of the data that you're moving. Right, this is very, very important. Okay, so we are dealing with an array of chars, right? Char is 1 byte, so this thing should be 1 right here. Okay, it's different if you have an int. If we had an array of ints, right, int equals 4 bytes, then we would have EDX, comma, ESI, comma 4. Right? This is very important because this corresponds to EDX plus ESI times 1. Okay, and we said this holds the first address, right? So if we're talking addresses, this guy could be 51370. This guy could be 71. 72, 73, 74, ... and so on and so forth. Right? Each address is 1 byte. So EDX in our case would be 51370. Right? And then plus ESI times 1. Originally ESI equals 0, right? So this is plus 0, and this just gives us 51370. Right, this is the first element in our array. If we increment ESI, then we'll have 51370 plus if ESI is 1, 1 times 1 gives you 1, and this will be 5, 1, 3, 7, 1. Right? Notice we moved 1 byte over, right? 1 byte over. So then if you increment ESI again, 1370 plus should be ESI would be 2 now, so 2 times 1, 51372. Alright, so then that moves us to the next address. Right, so this is how we're moving through arrays. Is you pick the first element of the array, and then you just hop from space to space depending on how big your data is. Okay, so if we had, like I said, if we had an array of ints, we would have, rather than 2, 1, and these guys, right? So let's get rid of these values. Alright, so let's say that, nope. Yep. So let's say that we change this to a 4, right? This would be 1370 plus ESI would be 0, so this is still the first element of our array, 1370. Right, so then the second one, ESI would be 1, right? So this would be 1 times 4 would give us plus 4. This will be 51374. So 0, 1, 2, 3, 4. Right? So this would be the address of the next element if we were dealing with ints. Right? This would be 4 bytes. And this would be element 0. And this would be the next 4 bytes. And this would be element 1. Right? And so on and so forth. So realize that this is extremely important because it tells you how many spaces or how many addresses you're hopping at one time every time you increment ESI. Now that we know how to access the array, let's create the logic for this, right? So anytime we have while loops or if statements or things that depend on logic, we are going to use compare statements. So we want compare B. Okay, this is super important, right? We're dealing with an array of chars. This is 1 byte at a time. We're dealing with 1 byte, so this should be compare B, okay? And then we should compare $0, comma, we will want percent EDX, comma, percent ESI, comma, 1. Okay, so in C, we have while my array doesn't equal 0, keep on implementing this. In assembly, you do the reverse. Rather than saying while my array doesn't equal 0, we want to say what if it does equal 0? And if it does equal 0, then we should skip over this stuff. So jump equal, right? If this number is equal to this number, then we want to jump to done. Okay, and then we're going to have done be some label down below when we're done with our loop. Alright, so now we have started the loop. So again, we have another if statement here. So again, we're going to be dealing with a compare statement and a jump. So compare B, we're still comparing bytes, and we're going to say $, space, right? This is just some number in the ASCII table. I don't know what the number is. You can look it up if you want. But this is fine, and this represents what we're trying to say. Your compiler won't be happy if you do this, but on the exam it's fine. And we want to compare with this guy right here, the element of our array. So then now we need a jump statement. right? So like I said, in C, we say if it does equal this, then do this, but in assembly we do the opposite. So we want to say, what if it doesn't equal that? So jump should be not equal. Then we want to go to our label skip 1. Okay, so the idea is we're going to skip over what we're going to code next. Whoops. So if it is true, we want to increment words by 1, right? So that would be inc. We said words is in EAX, so increment EAX. So if it's not equal to a space, we want to skip over this, right? So this is where our skip 1 should go. Skip 1. Right, all we're going to do is get past this little increment and make sure that we don't hit that. And then for the next statement, we says myArray or myArray equals a period. So we're basically going to want to copy the same thing and just change it. Instead of a space, we are going to want a period. Right, so copy and paste. Right, so and then instead of this space right there, this is going to be a period. And again, this is just going to be some number in the ASCII table. We'll say, is it equal to our array? Is it equal to our array? If it's not, then we want to skip again, but we're not going to go to skip 1. We're going to go to skip 2 and create a new label. Skip 2. Right, and then we're going to make this skip 2. Now if we go back, the last thing we need to do is increment I, and we said I was ESI, so that's just inc ESI. Now we're at the end of the code we need to execute in the while loop, so we should loop back, right? A while loop should continuously run through this code until myArray doesn't equal 0. Right, so we need a label down here. That's just a plain old jump, right? Because we want it to jump every time. Go back. Okay, and then now we need to choose where we're going to put go back. And go back should go right here. Go back. Because then this will check, does our array equal 0? And if it does, then we need to go to done, which we still need to create a label for. So let's do that as well. Right, so now done will go down here. So if it's done, it will hop over this jump statement. Right? So this will exit the loop. Then if we look back at the code, we need to increment words one last time and then return words. So increment is just inc EAX, and because words is in EAX, it will automatically be returned. So that's basically all you need to do, and the last couple of lines are popl %EBP and then return. Sweet, so that's it for this problem. I hope that helped out a little bit. I'm going to be coming out with a couple more examples on the ISA stuff and more on pipeline architecture and whatnot. So I hope you enjoyed it, and please give me feedback. Later, guys.